Okay, and we are live. Hello, everybody. Welcome to this amazing live where I'm here joined by Mircea, and we are going to give a lot of value to you. I'm basically going to hold my live FAANG interview with Mircea, who's going to be the interviewer, and I am going to basically take you through all the process of how to properly take an interview. I'm going to share a lot of value about my problem-solving thinking, how I'm going to use my bulletproof formula for solving coding questions, and especially during the interview, you are also going to see how I communicate my ideas to the interviewer, how I put him through my thinking process and line of thought so that he understands how I'm thinking about the problem and doesn't think that I just memorized the problem and I knew it from beforehand. Also, you are going to see how to be emotional stable during the interview, because I'm going to purposely make some mistakes and Mircea is going to put me in some tough spots. And you will see how I behave in those situations, how I communicate with him, and how I'm going to admit that I'm wrong, but we are going to work together through the solution and basically be a good team, which every company looks for, right? So yeah, this being said, also, of course, I almost forgot, you are going to learn a lot about how to write clean quality code, because as you know, it's super important that your code is readable and super quality. And yeah, first of all, let me introduce myself again. Most of you probably know me. I'm Andy. I'm co-founder and head instructor at Algo Academy. And tonight, I'm very happy to be joined by our amazing co-founder and CTO of Algo Academy, Mircea, which not only is a great programmer and is an expert in computer science, because in his curriculum, he has a peer-reviewed scientific paper on algorithms and data structure. He's an ex-national and international Olympiads, and also he has been part of, did I say about the scientific committee at the
scientific committee
in the International Olympiad of Informatics, right?
Yeah.
So yeah, that's cool. But not only that, he's also an ex software engineer for companies like Ubisoft, Adobe, Facebook. So yeah, he aced a lot of interviews and he really knows his craft. And I'm also an ex-Amazon and ex-medalist at the International Olympiads in Informatics. So happy to have you here. Make sure to take some paper, take a pen, take a lot of notes, because you are going to learn a lot. And one more thing that I'm going to mention, how this is going to go is that I'm basically going to have two roles. I'm going to have 2 points of view, right? I will be Andrei Chiriac, the person, the candidate who takes the interview. And I'm also going to be the narrator, Andy, and I'm going to talk to you after I do something in the interview. I'm going to explain to you to like enter narrative mode and explain to you why I did that and how you should actually treat this type of situations, right? So super stoked to have you here. Should we start, Mircea? Everything good?
Yeah, let's start.
Okay, let's start. I'm going to share my screen where we have a document, because as you know, interviews are taken on documents, thank God, not on whiteboard anymore. So the interview starts. I'm Andrei Chiriac. What do we have for you?
Yeah, so you are given an array of integers and an integer target, and we want to find a subarray that is equal to, with the sum equal to target. So, for example, if we have 1, 1, 5, 2, 1, 3, 10, and 2 and 1, and then the target 21, we can find a subarray, any subarray that has the sum equal to target of 21.
Okay, I see. So on this example, for this input, the output is 2, 6. So I guess this is the first index of the subarray, the left endpoint, and this is the right endpoint. So if I take a look at the subarray from index 2, 3, 4, 5, 6, the sum is 8, 11, 21. Okay, and this is why this is a valid solution. Okay, got it. I have a couple of questions. First of all, I should find any subarray with the sum equal to target. I want to make sure of that. If there are multiple ones, I can return any of them.
Yeah,
that's cool.
Any solution is fine.
Okay, got it. What happens if I don't have the solution? I don't see in the problem statement. If I don't have any subarray,
right,
with that sum,
you can return an empty array.
Okay, something to denote that there's no solution.
Yeah.
Okay, and also I see that in this example, all the numbers are positive and target is obviously positive. Are all the numbers always positive, or they can have any value?
No, as I stated in the problem statement, those are integers, so they can have negative values.
Got it.
And also target
could be negative.
Yeah.
Makes sense. Okay, guys, narrator mode. Do you see what I just did there? It's super important. It's the first step, the first thing that you should always do during an interview. Don't just jump straight into solving the solution, writing code, and thinking about the problem. What I want you to do and what you should do is make sure that you understand the problem. Read the statement, then always solve the example together with the interviewer, explain to him why that is the solution, and then, super important, ask questions. Any questions that are super related to this problem, right? And that are not in the statement, or maybe they are in the statement, but you just want to make sure. That's okay. Why you should ask questions? Well, first of all, obviously, you need to understand the problem well. These interviews are short, you need to be fast, and the last thing that you want is to think about a problem that you haven't understood well, right? Then, second of all, super important, it demonstrates great communication skills. It demonstrates that you think about details, that you take each scenario into account, and that is extremely important for an interview and for a FAANG job, as you are going to deal with a lot of scenarios and corner cases and stuff like that, right? So this is what I did. This is what you should do. Now that everything is clear to me, the problem is clear to me, I will continue the interview. I'm Andre again. Let's continue. Okay. So the first solution that comes to my mind, and the easiest one, is actually a brute force approach. The problem asks me for a subarray with sum equal to target. So I'm thinking about trying out each and every subarray from the array. How am I going to do this? A subarray is denoted by the left and the right endpoints. So I should try out each and every pair of these endpoints, which means I need two nested for loops. I'm going to have a for loop with an index I. Let's call I the left endpoint, which is going to go from 0 to the length of nums minus 1. And then another pointer, another index j, which should start from I. So for example, if I is here too, obviously j should start from here, not from 0, and should go all the way to the length of nums minus 1, being incremented by 1. Now, for each subarray ij, I need to also know the sum in order to check if the sum is equal to target. How I'm going to get the sum, because I want not to get it obviously with another for loop, I can use another variable and I can update that variable as I move with the index j. So for example, when I start with I from here, each time I start with a new I, I'm going to reset that sum to 0. And for each j in the second for loop, I'm going to increase the sum by nums of j, right? So on this example, for I2, sum is initially 0. When j is 2, sum plus equals 5, and now sum is 5. I check for target, no. Move to the next j, add 2 to the sum, now is 7. Move to the next, add 8, now is 7. And of course, when I finish the for loop with j, because I'm going to move to the next I should reset the sum, and that's why I'm going to reset it to 0 in the first for loop. Okay, so that would be my first solution. And if I think about the time complexity, it will be big O of n squared. And this is because I'm trying out each and every subarray, and there are at most n squared subarrays. Basically, the left endpoint, can take at most n, can take exactly n values from 0 to n minus 1, where n is the length of the array nums. And j will take n minus I values, something like that, but that's at most n. So it's big O of n squared. What do you think about the solution? Is it fast enough?
It's definitely a good start, but I think we can find something a bit faster.
I understand. Okay, narrator mode. What did I just do? I started with a brute force approach, and I didn't do it on purpose necessarily because I want to show great communication skills, although it's helpful for that. I'm going to explain it in a minute. But this is also part of my personal bulletproof formula for solving every coding question which I teach to my students, and I used my whole life after I discovered it. You always want to start with a brute force approach. And why is that? First of all, a slow approach like this, O of n squared, is always better than no approach at all, than no solution at all. And I actually have a funny story. I have a friend which actually got a job in Romania because he passed the interview, although he couldn't find the optimal solution. He just found the brute force approach. He explained it well, communicated well, coded it well, and he got the job. Why is that? Because nobody could find the optimal solution. But he was the only one who did an amazing job of explaining the brute force approach, while the others just underestimated it. And, so yeah, this is obviously. But second of all, super important, a lot of problems, a lot of them. The optimal solution will come actually from the brute force approach. You start with the brute force approach, you look at that algorithm, and you find the bottleneck. You find that part of the algorithm which is slow and can be optimized, maybe using a data structure, maybe using a technique, okay? But without starting with the brute force approach, it will be super hard to find the optimal solution from the get-go. So brute force approaches, and then the second point, yeah, it totally shows great communication skills. It totally demonstrates iterative thinking, right? There are super few people who came with optimal solutions from start. And actually that happened to me. I explained it in other lives. I was able to come up with those solutions because I had a background in the Olympiad in competitive programming. And the interviewer thought that I just seen the problem. I learned it by heart beforehand. And that's why I failed the interview, okay? So start with brute force approaches. They are great. The interviewer gets a grasp of how you think, and yeah, communicated well. Now back to the interview. Also, sorry, one more thing. After coming up with a brute force approach, ask the interviewer, is this approach good enough for you? Do you like it? Should we code it, right? Don't just go by it to the next solution, or even worse, start coding it without the interviewer telling you to do so, right? Discuss with him, ask him if he likes it, and only then the interviewer will give you instructions. Okay, back to the interview. So we can do better here. Okay. So we can have a faster solution than big O of n squared. This means that I shouldn't have two nested for loops, because that's what causes that time complexity. So instead of trying out both each value for I and each value for j, I'm thinking about only fixing j, only trying out each value of j, of the right endpoint. Okay. Now, if I do this, let's say I try out each possible j, right? For j in range 0 and nums. This is my right endpoint. In order to have a valid solution, a subarray with this right endpoint and some target, what should happen is that the sum of some subarray that starts from some index I, which I don't know, I have to find it, and goes all the way to nums of j, should be equal to target. Okay. Because I'm not able to fix this value of I anymore, I'm thinking about doing something else. Partial sums or prefix sums can help us here a lot because they help us, first of all, finding the sum of a subarray in constant time. But instead of having this sum with all these elements, I can reduce it to only a difference of two values. So prefix sums, what I'm talking about, basically, let's say it's an array. Prefix sums of I will be basically the sum of all the numbers in the array nums, starting from num 0 all the way to the index I, from nums I. Okay. Now, if I have these prefix sums, the sum of this subarray from I to j is basically the sum of the prefix from 0 to j minus the prefix from 0 to I minus 1, right? So I can rewrite this as prefix sum of j minus prefix sum of I minus 1. Okay. This is a little better because I'm going to know the value of j because I fix it. I know the value of prefix sum of j, and I know the value of target. So for this to happen, I can rewrite this. If I take this term and move it to the right and target to the left, actually prefix sum of I minus 1 should be equal to prefix sum of j minus target. Okay, this is great. So basically, for each value of j that I'm going to try out, now what I need to do, I need to find an index I, any index, such that this prefix sum is equal to this value which I'm going to know, right? I know j, I know prefix sum j, I know targets, I'm going to know this difference. Okay. And now, this does ring a bell for me because I should look for a specific value which I know in a collection, in a set of values, which are the prefix sums up to that index j, right? I should be less than or equal to j, so this prefix sum of I minus 1 is to the left of prefix sum of j. And I need to look for a value in a collection of values that I've already iterated through, which is great because there is a special data structure which was designed to do exactly that in constant time, and that is a hash table, how it's called in classic computer science, or in Python, it is a dictionary. So I'm thinking about using a dictionary while I traverse the indices with j. I'm going to have all the prefix sums that I already iterated through inserted in a dictionary. So for an index j, I can look for this value in the dictionary to see if I have that prefix sum, right? So this is the idea. It's pretty clear to me, but I'd like to show you on an example to understand better. Is that okay?
Yeah, definitely.
Okay. So let's take this example. For this nums, I'm going to copy paste it here so we can see better. If this is nums, we have prefix sums. Okay. So we have 1, 2, this sum plus 5 is 7. Then we have a 9, we have a 10, we have a 13. 23, 13, 23, 25, and 26. Okay, these are the prefix sums. Target is 21. Okay, I'm going to have my dictionary. I wanted to name it dictionary, but that's actually not. Let's call it dictionary for now. I'm going to find a more meaningful name. Okay, it's initially empty. When I try out this J, its sum is 1. So I need to look for 1 minus target minus 21 for a minus 20. I don't have any sum in the dictionary. Okay, so I don't have a solution. Now, when I try out this J, I'm looking for prefix sum of J2 minus target minus 21. I'm looking for a minus 9. Oh, sorry. I have no solution for this J. That's my bad. I forgot to mention it. If I have no solution, before I move to the next J, I'm going to insert the prefix sum in the dictionary. And also, I just realized it's not enough to know if you have a prefix sum with the value that you're looking for, but because we need to return indices, I need to actually know what's that I that corresponds to this prefix sum, right? Because I know the J, the right-hand point, and if I have a solution, I should also know the I. So what I'm actually going to do is for each prefix sum that I insert in the dictionary, I'm going to point it to the index that it corresponds to. So right now, after this J0, I'm going to insert 1, which will correspond in Python, it's 2 points, which will correspond to the index 0, the index of that prefix sum. Then for 2, as I said, I have no value. I'm going to insert this sum, which corresponds to index 1. Then 7, I'm looking for 7 minus 21 minus 14. I don't have any minus 14 in the dictionary. So I'm going to insert sum 7, which corresponds to the index 2. Then sum is 9. I'm looking for 9 minus 21 minus 12. I don't have a minus 12 in the dictionary, so I don't have a solution. I'm going to insert the prefix sum, which points to the 0, 1, 2, 3, to the index 3. Okay. And for this example, 2, 6, I think we have a couple more steps. We will find it when J is 6. We've been through 0, 1, 2, 3. Okay. Can I fast forward a little bit? Is it okay?
Yeah, of course.
Okay, cool. So basically what's going to happen is for this 10, minus 11, I don't have it. I'm not going to have a solution. I have 0, 1, 2, 3, index 4. Then also for this 13, I'm not going to have the minus 8 that I'm looking for. So I'll have 13 corresponding to index 5. Okay. And now for this 23, when J is 6, I'm looking for 23 minus 21, which is 2, a prefix sum of 2. And when I look into the dictionary, it's the first time that I found a prefix sum that I'm looking for, and the sum is 2. That corresponds to index 1. Okay, so what this means is that for this J, which was 6, for sum 23, I got a prefix sum of 1 is equal to what I'm looking for. But that doesn't mean that the left-hand point is 1, as we can see here. Why is that? Because this value that I'm looking for should actually be prefix sum of I minus 1. So the left-hand point minus 1. So to this value, I should increment it. I should increase 1 to get the real left-hand point I. And this is how we are going to get to the solution in this example.
Yeah, makes sense.
Makes sense?
Yeah.
Okay, narrator mode. It was a lot there, but I hope you stick with us. Let's see, Mircea, what happened here? So first of all, you should notice how I took Mircea through my line of thought, okay? I tried to explain to him as smooth as possible, step by step, how I'm getting the solutions, which is exactly what happens in my head, right? With a lot of experience, you're going to see that your brain will jump maybe 5 steps and you're going to get it like that. But go step by step when you explain to the interviewer the solution, right? It's super important to show great communication skills. If somebody will want you hired or working in their team, you should be able to work together, to come up with solutions together, and to discuss problems, ideas together, right? So you need to explain well. So what I did is that step by step, I explained the process of basically getting the idea of the prefix sums, then that I'm looking for a value in a collection and I needed to do it quickly, and there's a data structure designed for that, right? So it seems very naturally, although I got the idea like that in my head, it's very naturally, and the steps are super smooth how I explained it. Then a super important thing, after I explain the solution, as you can see, what's here, it's pretty abstract, right? You're working with prefix sums of I, of j. It's not easy to understand it at first sight, but especially if you don't know how to explain it well, abstract things. So what I want you to do, and what you should always do during an interview, after you come up with the general solution and you explain it generally, please take an example. Take the example provided by the interviewer, or come up with your own example if you think it's more appropriate, but go step by step, by hand, dry run basically, right? The dry run is the term. Dry run your algorithm on the example, like together with the interviewer. Okay. Is there anything else that I've done here?
Not really. Maybe I can add that because you're talking while you're explaining things, even if you don't know how to solve the problem, the interviewer will actually help you with hints at some point.
Oh yeah.
But if you don't say anything, you just think on your own, I cannot help you in any way.
Yeah, for sure.
In this case, I didn't have to, but if the problem is harder and stuff like that, if you go through your thinking process, I can come in and help you with some hints, maybe.
Yeah, of course. It's super important to talk out loud. And even if you don't have a solution like Mircea mentioned, try and avoid silence at all costs, but also try not to overdo this and like talk a lot, but like, right, not on the subject, not on the talk, basically ideas that are clearly not good, right?
Yeah, it's important to make me, the interviewer, actually understand what you're thinking. If you're just blabbing around and you're confusing me, it's not good.
Yeah, that makes sense. Yeah, and even being honest, it's better than staying silent, right? You can just be honest. Look, these are my ideas. They are good, they are bad. This is all I've got. Please help me, right? And the interviewer will appreciate that. So it's super important to communicate.
You want to be a software engineer, right?
Go to algoacademy.com. Pick a question. Read the statement. Watch our video explanations that not only cover the solution at hand, but also develop your thinking process. Ready to code? Use our step-by-step coding tutorial. Write the code for the current step. Validate the step. Failed? Check our code, see what you did wrong, or just replace your code with ours. Validate again, and repeat. algoacademy.com is the optimal way to prepare for your coding interviews, become a better software engineer, and land your dream job.
Stop wasting valuable time and start your programming career today on algoacademy.com. See you there.
Okay, back to the interview. I'm Andrei. Okay, so this was for my example. Should I explain the time and space complexity of this algorithm, or do you want to code it? How do you want to go about it?
Yeah, let's code it first, and we can at the end we can see each step.
Okay.
And calculate the time complexity better.
Okay, that's great. So I'm going to code in Python, and as I'm not provided the template function, I'm going to write it myself. So I'm going to have a function. What should be the name? Well, I'm looking for a subarray of a given sum. So let's call it subarray of given sum. And the arguments are the array, nums, and the extra integer target. Okay, so let's see. I'm going to use the dictionary. Okay. And as I said, now I should come up with the name of it because I haven't. So basically what I'm doing, I have partial sums, prefix sums, and for each sum, I point to the index. So I think a pretty good name can be index of sum. It's going to be a dictionary, okay, which is initially empty. And I'm going to iterate with j. So for each j in range from 0 to the length of nums minus 1. Now, okay, I need the prefix sums. So I'm going to need an extra array for the prefix sums. Okay. So what I'm going to do is prefix sums. I'm going to have an empty list initially. Okay. And I want to compute prefix sums of j. Prefix sums of j. Basically, prefix sums of j is the previous prefix sum of j minus 1 plus nums of j. So what I'm going to do is I'm going to take prefix sums, the last element basically of prefix sums, and to it I'm going to add nums of j, which is my current element. Okay. And I'm going to take this and prefix sums, I'm going to append to my list this new sum. Okay. Now I have the prefix sums. So what should I do is try out each and every j. So for each j in range from 0 to len nums, I'm looking for a solution with this j. So as I explained here, I need a prefix sum which is equal to prefix sum j minus target. Okay, let's have this difference. And I'm going to look for this difference. Okay, so if prefix sums of j minus target, if this difference exists in my dictionary, that means I totally have a solution for this right endpoint. So what's going to be that solution? That solution is going to be index of sum of this difference. Okay. No, not this one. Okay. So this one, right? It's going to be a pair consisting of, this will be the first index to which, as we discussed, I should add 1, and the right endpoint is our j. Okay, cool. Now, what happens if I have a solution? I return it and I can end the algorithm. Cool. If I don't have a solution, what should I do? I should insert in index of value, index of sum. That's it. My sum, which is prefix sums of j. Okay, and it's going to point to the index j, the index of it. Okay, all right, I added it. Okay, and I think that's it. Of course, if the for loop terminates and I don't have a solution, I should return the empty list, you said, right, for that. Okay. This is the code. Narrator mode. You can pause the video and think about what have I done here and if I can improve anything. Do you think how I coded it? Do you think this solution is optimal? Pause the video. Mircea is ready to give me feedback, but you can pause the video and it's a good exercise for yourself. Think about how would you have done it and if you could have done it better, right? So back to the interview, I'm Andrei. I think that's the solution. What do you think about it?
Okay. Can you explain again what the prefix sums of dot, colon and -1 does?
Yeah, you are right. That was my mistake. I wanted to get the last element from the prefix sums, but what I'm doing with this is that, what am I doing with this? I'm actually getting the whole prefix sums list, right? Because I'm getting the subarray that starts from index 0 and ends at index -1.
Yeah.
Right?
Something like that. I'm not sure what it does exactly, but it returns on subarray.
Yeah, it's a subarray, yeah. So, okay. This is what I meant to do. Okay.
I think that it's kind of hard to read because you're using prefix sums of j minus target multiple times in a way.
Okay, I think I get what you're saying. Now that I actually look at it, it's the lines seemed a bit long for me and yeah, quite complicated.
It's not easy to go through each line and understand what it does because you have too many things on one line, for instance. Maybe we can use an extra variable with a meaningful name.
Okay, that makes sense. So let's see. Okay, this is okay. Let's see how would I read it, right? For each j here, prefix sums append prefix sums of -1 plus num j. Okay, I get what you're saying. It's prefix sums 2 times. Yeah, it doesn't look good. What I can do is basically, first of all, compute this sum. So what is this? This is basically the current prefix sum, right? Prefix sums is my array. Okay. Prefix sum is prefix sums -1 plus num j, and I can append prefix sum, or I can call it sum.
Okay, I was more talking about the second for loop. But yeah, that's also better, different, I don't know.
Yeah, doesn't seem like a lot. Okay, like a lot better. I understand. So the second for loop. Okay. For j in range. Okay.
Maybe because you use I, J, I'm not, for me, if I read it without having some comments on it, I'm not sure which is the left pointer, which is the right pointer.
Okay, got it.
You return that thing, I don't know what's that, like a bit scary.
Yeah, okay, I see what you're saying. Okay, so first thing that I can notice is that I have this difference 2 times, and it makes the lines of code super long.
Yeah.
So I think the first thing that makes sense to do here is actually say that, okay, this is the difference that I'm looking for. Difference. Yeah. Okay. I'm looking for this difference, which is prefix sum j minus target. Okay. And now, of course, I can say if difference in index of sum, return index of sum of difference. Okay, this is +1 and this is j. Okay. About the other comment that you mentioned, yeah, probably probably using like right instead of j as the iterator variable could be a little better.
Yeah, and also use a left variable, and then you return left and right. And it's clear when you read it, it's clear, oh, this is the left thing, this is the right thing.
Yeah, I get it. Okay, so instead of j, I can call this right, so we know that it's the right endpoint. I want this difference if it exists in the dictionary. Let's be clear about this. We know the right one. We know the left one exists, a solution exists. So we'll get the left endpoint of our solution, right? Which is this index +1. And then I can return left, right.
Yeah, this looks much better.
Yeah, I also like it better. Yeah.
It's way better to read it, like when you go down one line, you understand what's going on there.
Yeah, I totally agree.
One issue I have with the first for loop, what happens, you're actually trying to access the last element, but at the beginning, prefix sum is empty.
Yeah. And that's totally an error. Yeah, you're right. Okay. Narrator mode, because I don't want to forget this. What happened? I thought you also thought about and came up with these improvements that Mircea pointed out to me, right? I had duplicate code. A code quality and readability rule never have duplicate code. If it is as simple to remove it, I mean, it wasn't like a very bad duplicate code, like 3 lines of code and then the same 3 lines of code. But as Mircea pointed out, that difference is quite lengthy and you use it 2 times and it just doesn't look good. Use a variable. And the second point, super important, use meaningful variable names. Who is I? Who is J, right? Okay, in the first for loop, you can use an I or a J because we're not talking about the left and right endpoints of the solution. That's okay. Everybody knows that there are iterator variables and you can use it like that. But in the second for loop, left and right are much better names because now we are already looking for the solution, right? J, is J the left endpoint, the right endpoint? Who is, which one of it is it? If someone reads your code, which happens a lot, of course, in FAANG, and they don't know already the solution, or you haven't explained to them the solution, they are not going to easily, figure that out for themselves. And yeah, the left, the right, using variables. Okay, back to the interview. Cool. So in the first for loop, okay, yeah, you are right. I'm trying to access. Okay, one idea that I have to fix this, of course, is I can start with J from 1 actually, and the first prefix sums of 0, I can basically initialize the prefix sums list with nums of 0, basically, right? So prefix sums of 0 will be nums of 0, the first element. And now that I start with 1, yeah, that should be good.
Looks good. Can we optimize the memory complexity? Maybe.
Okay. So first of all, let's figure out what is, right, the space complexity. Let me figure it out first. Okay, so what I'm doing, the extra space that I use is the dictionary and also the prefix sums list. Okay. Both of them will take big O of n space, as in the dictionary, I'm going to insert at most n prefix sums, right? In the worst case, when I go with the right endpoint until the end of the array, I'm going to have inserted all the sums. So this is big O of n, and the prefix sums are also big O of n because they have n elements. Oh, okay, I see. I think the answer to your question is theoretically no, we can do better than big O of n space complexity because my solution relies entirely on the dictionary, right? But I think that you mean that we can like not remove, how do you say, not use an extra array like prefix sums. Yeah, and I kind of thought about it when I've written the code, because something didn't seem right for me, because I made this for loop with the J, which is just for computing the prefix sums. And then I kind of made the same for loop when I had the J and when I started here from 0, and they were the same. And something was like, okay. And now that I think about it, what happens is that for each right endpoint, and by the way, sorry, I also forgot here this J, and yeah, let's also, okay. So for each right endpoint, okay, basically I need only prefix sums of right and the dictionary. Kind of that's it.
Yeah.
So I don't need the entire array. I just need the current prefix sum because the other ones are already in the dictionary and I'm going to find what I need there basically. Yeah, okay. So instead of using an array, I just need the last value. So I can have a variable which only like stores the last prefix sum. That makes sense. Okay, so I'm not going to have this for loop anymore. I'm going to have the prefix sum, which is now a variable, is not a list anymore. Okay. I start with right from 0. So I'm, okay. So prefix sum, okay, yeah. So prefix sum will be initially 0, and for each right endpoint, it makes sense now. Yeah. To update the prefix sum, add it by nums of j, right? Nums of run. Yeah, of course.
Yeah. And now we don't have that array.
Yeah. Yeah, it's better space complexity.
Change use the prefix from some variable now instead of the array.
Prefix sum. Okay. Yeah. So we have the prefix sum. This is the difference. The difference. Okay. Index of sum of prefix sum is now right.
Great. Now it looks even better.
Yeah, it's cleaner and shorter. Okay, narrator mode. What happened here, Mircea? After discussing the error that I've actually made purposely with that -1, the last element, when the array is empty, this is a spot, this is a pretty tough spot. The interviewer will put you on tough spots. And what I mean by tough spots is really the way that you handle them. What I want you to take away from this, from our experience and all of our students, is that you don't need to be perfect, like in order to pass the FAANG coding interview. I know there are a lot of candidates. Everybody wants to be at FAANG. The interviews are not easy, the problems are not easy, but you don't need to be perfect to enter FAANG, right? You don't need to have perfectly written code in 10 minutes with no errors and stuff like that. That is super impressive, don't get me wrong. And with a lot of practice, and if you have momentum on coding and solving coding questions, you will be able eventually to be able to do this perfectly from the first try. But if you don't, that's cool. What's more important than that is to have an open mind, right? And to admit when you are wrong. Listen to the interviewer, don't disagree with him, or I don't know, get triggered and or get scared or freeze, think like, oh, he pointed this mistake to me, I made this mistake, sure, I'm going to fail, this for nothing, I'm going to wait another year. No, just chill, right? There's nothing you can do about it, and it doesn't matter that you made a little mistake. Do you think every FAANG software engineer writes the code from the first try, from the start, and pushes it like directly to production? No, it's not going to happen. That's why there are code reviews. That's why other peers look for your code at those companies. And that's exactly the mindset that you should have during the interview, okay? It's okay to have mistakes, but treat this like a code review from your peer with no pressure, and really ask yourself, okay, is the interviewer right? Because he might also ask you a tricky question, right? Maybe your solution is perfectly fine, and he's going to ask you, what about that? Doesn't look right to me. Keep a clear head and think objectively. Is he right? Is he not? What can go wrong? What is an edge case? And if you find that you have a problem, okay, communicate. Tell him, I think this is the problem. I think this is what happens. With an open mind, you will find the solution together. He will guide you through the solution. And they just want you to see that you are adaptable. And when you make a mistake, you find the solution, you fix it, and everything's fine, right? So this is what happened here. And also the second important thing, the interviewer asked me if we can improve the space complexity, right? Again, don't panic. Don't think that my whole solution is bad. How could have I not thought about it? It's not optimal. I've written it. It's in vain, right? I have to throw it to the trash. No. Again, open mind and really think about, what am I doing? What's my space complexity? I don't think I can improve this, but maybe I can improve this. And he's going to guide you. As you communicate, he's going to guide you and point you to the solution even better. Okay? Back to the interview. I'm again Andrei. Okay.
Let's think about some test cases and maybe dry run the code with them.
Okay, that totally makes sense. I've already dry ran my approach, my theoretical approach. All right.
Yeah, I'm thinking more about edge cases, not the whole.
Yeah,
long.
that's what I was thinking about too. So let's see, what could be some problems, some edge cases. The dictionary is initially empty. I try out each right endpoint from 0 to the end. Okay, that's good. Now for each right endpoint, I have a prefix sum, I have the difference. Okay, so I'm trying out each right endpoint. That should be fine. I'm thinking whether I'm missing some left possible endpoint. Because the right is clearly trying out each of them. It's all about my dictionary. Do I have in my dictionary all the sums that I actually need for each right endpoint? For each right endpoint, I actually... Okay, I actually inserted. What I insert? The prefix sum. So prefix sums of 0, prefix sum of 1. Oh, yeah. I think I understand. Yeah. So, yeah, you're right. Like it is an edge case. What happens is that the first prefix sum that I insert is we write 0. So basically prefix sum of 0. So nums of 0. But that prefix sums of 0, as we've talked about, corresponds actually to I equals 1.
Yeah.
And when the solution of the problem is for I equals 0, starts from the first element, I basically need prefix sum of -1, quote unquote, the sum of the empty prefix, which I don't have it because I don't have right equals -1. Okay, so how I can fix this is that I'm going to add that sum, which is 0, the empty sum of the empty prefix. I'm going to initialize the dictionary with that sum, which, what index does it correspond to? -1 is fine, because if I'm looking for 0, I'm going to find index -1 and add 1, which corresponds to what I want left to be equal to 0. Yeah, so 0 and -1. And that should solve the edge case. Yeah, that's it.
Yeah, that looks good. Okay, I was thinking maybe we can run like a small example.
Sure. Let's see. I'm trying to think if there's another edge case and you want to like to kind of assess me on that. But for I equals j, no, I treat that. Okay, let's see. A small example, right? What should be an interesting one? Let's say I have also negative numbers because we haven't talked about it.
Yeah.
-2, 3, maybe we have -10, and maybe we have 7. And let's say target is 0. What about that? So I have a subarray of sum 0, which is this one, right? I should find this subarray. So what am I going to do? I start with index of sum. I only have 0 and -1. Then I have my variable prefix sum, which is 0. initially, and right is 0. I'm going to write all the variables and update their values.
Like in debugger.
Like in debugger, exactly. Right is 0. Prefix sum gets increased by -2, so now it is -2. Difference is -2 minus 0, which is -2. So I'm going to have difference is -2. Is -2 in index of sum? No, it's not. So I'm going to have no solution. I'm not going to execute anything, and prefix sum -2 with right, which is 0. So I'm going to add -2 and 0. Then the next right becomes 1. Right becomes 1. Prefix sum becomes 1. The difference is 1. Do I have a 1 in the dictionary? I don't. Prefix sum is 1 and right is 1. So now I have the pair 1 corresponding to 1. Okay, one more time. Prefix sum is -9. The difference is -9 minus the target. Okay, -9. Do I have a -9? I don't have a -9. Right is now 2. I forgot to update this. And I don't have a solution. I'm going to have -9. The prefix sum -9. Is it -9? Yeah. Corresponding to index 2. And finally, when right becomes 3, the prefix sum from -9 is now +7 -2. The difference is -2. And I'm looking for -2 in index of sum, and I have it, and I have 0. So I'm going to return, left is going to be equal. Now I enter it, and left will be 0 plus 1, which is 1, and right is 3, and we return 1 3 basically.
Yeah, that looks great.
Awesome.
Can we look over the time and space complexity? The space we talked about it.
Yeah, the space we discussed. Okay, the time complexity, I confidently say it's big O of n, because what I have basically is a for loop. I try out each right endpoint, and there are obviously n of them. So this is n iterations. And basically what happens inside this loop, of course, all of these are constants, and I'm looking for a value in a dictionary, which is constant. I am, also getting the value, looking for the value in a dictionary, and I am updating or inserting a value in a dictionary. All of this with dictionaries are constant. So the code inside the for loop is constant, and because I have n iterations, the time complexity will be big O of n.
Yeah. Looks great.
Okay.
All right.
Do we have any more time?
Fine.
I'm curious how much time we passed. Don't ask the interviewer narrator mode again.
I have no idea.
Okay.
I'm thinking of a follow-up if you're up for it.
Yeah, let's go.
Okay. I'll change the. Can we swipe up?
Yeah, sure.
Okay. So I want to change the problem. We'll always have non-negative integers. So no, we don't have negative right now. There's
Only positive
only
integers.
positive and 0 maybe.
Okay.
And the question is, can we do it in with constant extra space?
Okay. Got it. Narrator mode. After you are done solving a question, very often, if you have time, that's why I asked Mircea if we have like time left. Usually you are going to have time left, or it's good to have time left, and the interviewer will ask you for a follow-up. What is a follow-up? The coding question is basically the same question in which one constraint, one property is a little bit modified in order to optimize the previous solution, which you have just discussed and coded, to optimize either the time or the space complexity, right? So for example, here, Mircea gave me the problem with positive integers and also gave me the reason. I'm going to make the problem more specific, give it a special property, only positive integers, and you should use that. That's what it means, a follow-up with a special property. That special property is always the key to the solution. The follow-up solution with, in this case, constant extra space, which the interviewer wants, is not doable if the integers are not positive. So always these are hints. You should always use those things as the foundation of your new solution, right? They are the best hints and they are basically the solution of the problem if you know how to use it, okay? So back to the interview. Okay, I understand. So now we have only positive integers. Okay, I'm thinking how to use this special property with positive integers because I'm feeling that only with this property we can reach to a constant extra space, and with positive and negative we need the dictionary. So how do the positive integers help me? Okay. If I have positive integers, I'm actually going back a little bit to my brute force approach. Because if I have positive integers and I have a current subarray, right? We can take this one, some left and right endpoint, right? Each time I increment the right endpoint, I add a new element to the subarray, and now, because all the elements are positive, I'm actually surely increasing the sum of that subarray. So for the brute force approach, for example, if I tried out the left endpoint, let's name it I for the sake of this example, and try out each and every j, the first time that I found that the sum of the current subarray is greater than target, I can break out of the second loop. I don't need to increment j anymore, right? If I get a sum of, I don't know, 30 and target is 21, why would I look for a greater j? I'm just going to increase the sum, and that's going to get me further to the solution. And also, if my current subarray, for example, 5,2, if I have a subarray and the sum of that subarray is less than target, I should take more elements. And I can do that from the right. Okay, I think I got it. I think I got it. Yeah. So I should use the fact I'm actually going to combine kind of the two solutions, not combine them, but instead of trying out each and every subarray, I'm thinking about having my current subarray, some I and some j, which are two indices. And if the sum of this subarray is less than target, increment j, the right endpoint. And if the sum of the subarray becomes greater than target, increment I, because I need to reduce the sum. So this brings me to a sliding window technique. I'm thinking about the sliding window using two indices. And let's take actually this example to make it more clear. Or let's see, is this a good example in order to, I think I can I think I'm going to change a little bit the example, if that's okay.
Yeah. Sure.
Let's say I have a 5, I have a 7, I have a 2. This sum is 14 so far. Okay. 1, 2. What if I'm looking for a sum of 4? Or a sum of, I have a 7. Okay, I think this works for now, right? And for example, if target is 4, this is a simple example. But what I'm talking about is I am still going to try out each and every right endpoint. But the left one, I'm not going to have a for loop for that. I'm going to start with it from 0. And my for loop will try out each and every right, each and every j, as we called it. And I'm going to have the sum. And let's see. I want to see, is there a solution with the right endpoint in 0? Well, when right is 0, I'm going to increase the sum by 5. And I can see, how's this sum compared to target? It's greater. So I'm not going to, target is not good that it's 4 because it's, okay, let's do 9. Now it's going to be fine. Okay, so sum is 5, right? How is the sum compared to target? 5 to 9. 5 is less than 9. What does it mean? I need a greater sum. I need more elements. So I need to increment right. With right is 0, I'm not going to have a solution. So I'm going to move to the next right. I'm keeping left where it is. And I'm going to add 7 to the sum. Now the sum of the current subarray is 12. This is interesting. The sum is 12, is greater than 9. So there's no point in trying to increment right to increase the sum. I need to reduce it, and the only way that I'm going to do this is by incrementing left, by removing elements from the left of my subarray, right? So I'm going to increment left, which is now 1. Of course, now this element is not part of my current subarray anymore. So the sum is 7. And now I stop. And I check again. How's the sum compared to target? It's less. What should I do? Well, it's time to increment right. If I increment left, the sum is just going to be decreased. So now I'm going to go to right equals 2, and the sum will become 9. So this is how I find it on this example. I know it's a pretty small example, but it really helped me to understand this better. Yeah, so basically, with a for loop, I'm going to try out each and every possible right endpoint. And for each right endpoint, as long as the sum from left to right is greater than target, I'm going to increment left. When that doesn't happen anymore, I either have a sum which is equal to target, or the sum is less than target, which means I should move on to the next right, if that makes sense. But the thing with the left pointer is that, unlike in the brute force approach, I'm not going to, reset it every time, start from 0 every time, but we'll just move to the right. Okay, so for the right, I have the left. For the next right, the left stays there. Is it okay if I write the code and maybe I dry run on another example, or do you want to dry run on another example right now to understand it?
We can write the code. I mean, I saw what you did there with the example. So
it's a small example. That's why I wanted to ask to, like to clarify this with you. Okay, narrator mode, back again. As you can see, again, just a reminder, what have I done here? The same as before. I'm explaining a solution. I'm taking the interviewer step by step through my thinking process, right? Through my line of thought. But then remember, these are only abstract things. When I talk about an I, a j, a sum, take an example, even a small one can do the job. If you think a small one wasn't enough for the interviewer to understand, you can ask him directly, like be open about it. Do you want me to take another example to dry run it for you to understand better? Or should we write the code, right? Yeah, back to the interview, right? I'm Andrei. Okay, so again, the function, which is going to be subarray of given sum. I have nums, I have target. And let's see. I'm going to try out. It's not J anymore, it's right. Okay, for each right in range 0 len nums. Okay. I'm going to start with my left index from 0. And for each right, of course, I need to have the sum to know what its value is. So sum is initially also equal to 0. So I can do left sum equals 0, 0. For right in range, I'm going to first of all increase the sum as I have a new value in my current subarray from left to right. And what happens now? Sum is either target, which is great, or it's greater, or it's less. But I can first treat the case where sum is greater than target. And while that happens, I'm going to subtract nums of left. This is not I. And of course, then I'm going to increment left while this happens. Okay. Okay. Cool. Now, when this while loop terminates, sum is less than or equal to target. So if it's less than target, I should continue the for loop and increment right, which is going to happen naturally. So I want to check if this sum is actually equal to target. And if it is, we have a solution. So we should return it. It's left and right. And if it's not, when we reach this line of code, sum is less than target. So I'm just going to move on. Okay. If the for loop terminates and we haven't returned anything, so we reach this line of code, I'm going to return the empty array.
Okay.
Yeah.
Let's think of maybe some edge cases. I think there is a small issue with the code in a particular case.
Okay. Narrator mode, real quick. You can also think about this, use it as an exercise, pause the video. What's wrong with this? What could be a corner case that I purposely haven't thought about, or you maybe haven't thought about? Back to the interview. Let me see. Okay. I guess a possible problem, usually when using 2 pointers or sliding window, I'm afraid that left actually shouldn't surpass right. I'm thinking about something like that. Can it happen? Let me see. As long as sum is greater than target, I reduce and I increment left. There is something that I'm thinking about, and I'm actually thinking about what if we have an element from nums which by itself is greater than target. right? In this simple example, left is 0, right is 0, sum is 100. Is sum greater than 90? Yes, it is. So I'm going to increment left. So right is 0, but left becomes 1.
Okay. And it goes to the next step in the while loop.
It should, yeah, it goes, yeah. Okay.
And it tries to access
but
nums of 1, maybe. And it will blow up.
I see what you're saying. For this example, I think it doesn't, but let's see. So left is 0, right is 0. Okay.
Oh, because you're subtracting.
Yeah. So sum is 100. Is sum greater than 90? Yeah. But I'm subtracting, yeah, exactly, nums are left. So sum becomes 0, actually. If this happens, left indeed might become right plus 1, so surpass right, which is technically not great, but sum then becomes 0. And for this example, it's not, oh, but there is, okay. This is actually tricky. Like, this is a good discussion because all the elements in the array are positive. Technically, I think for it to make sense, target should be positive.
Yeah, but you can get a negative 1.
Got it. Because this is where the problem arises. If I get a negative target, right? Like in this example.
Let's take an example, actually.
Yeah. Even in this, this is not actually that great. Yeah, let's take another example. Okay. What?
Oh, or maybe 90 and 90. What happened then?
90 and 90?
Yeah, like this, yeah.
Sum is 0.
Oh, it's sum greater than target. So no.
Yeah, no. If target is negative, I was thinking about, for example, a negative target like minus 90.
Yeah, okay.
For example, this. Yeah, this is a problem, right? Because after the first iteration, left is 1, right is 0, sum is 0, because we subtracted 90 from 90, right? But we enter again the loop because 0 is greater than target. And we try to access nums of 1, which is not existent.
Yeah, and you get a runtime error.
Yeah, okay. So in the case the target is negative, we should fix this. How can we? Well, actually, you know what? I think we should make sure. I mean, we can check, actually. We can make sure by checking if left is always less than or equal to right. So as long as left is less than or equal to right, okay, so we have something, we have a valid subarray, like at least an element, and the sum is still greater than target, okay, you can increase left, maybe it becomes right plus 1. But after that point, when left is right plus 1, we surely won't touch the while loop. We won't enter the while loop, yeah. And actually, yeah, that's good, because right is less than len of nums. And if we make sure that left is also less than or equal to right, we won't access, we won't exceed the array's bounds, right?
Yeah.
Right now. Okay. So in this case, yeah, when left is 1, right is 0, it's not going to execute. Is sum equal to target? It's not. Okay, but what if we had another element? What if we had... it doesn't matter because target is negative. We won't have a solution.
Yeah.
Yeah. Okay.
Yeah, I think it looks good. Maybe we can go to time complexity.
Okay. Yeah. So space complexity obviously constant. We just use extra variables. In terms of the time complexity, yeah, it's a beautiful sliding window approach. And the time complexity is linear, it's big O of n, but I don't think it's super obvious or trivial. Why is that? I actually love this technique because when you look at first sight, you see a while loop inside a for loop, and that can, a lot of people say it's n squared, it's n squared. But actually what happens here is we know for sure this for loop makes a total of n iterations. That's clear, where n is the length of nums from 0 to n minus 1. But this while loop doesn't make always a constant number of iterations, right? It depends on the left, on the right, on the sum. Maybe when right is 0, it will make 1 iteration. When right is 1, it makes 5. When right is 9, it makes 4 of them, and so on. So because the number of iterations in this while loop is not constant, I'm thinking that the time complexity is actually amortized. And I'm thinking about, okay, I don't know how many steps it will do at each point, but I can find out how many steps this while loop will do in total throughout the whole algorithm, right? And what happens is that actually for each iteration of this while loop, we increment left. We increase it by 1, right? Left starts from 0. We never decrement left or decrease it. We only increment it. So it only moves to the right, basically. And is always less than or equal to right? Which is less than n. So basically what happens is that left starts from 0, moves to the right to at most n minus 1, the last index, and only gets incremented by 1. So this left index will actually move n times. And of course, same for right, which it's clear from the for loop that starts at 0 all the way to n minus 1 plus 1 n times. So yeah, if for each iteration in the while loop, we increment left, and we are going to increment left for n times, this while loop does in total n iterations throughout the whole algorithm, the for loop n iterations. Or another way, I guess you can look at it is, obviously we have n elements, and each element in the array nums is visited at most twice, right, by right or left. I think it's a visual way, it's a more visual way to think about this. So yeah, the time complexity is big O of n.
Yeah, that sounds good.
Okay.
Yeah, I think we covered everything.